Open any of the 8 feature screens in this project before this commit and you would find the same pattern copy-pasted 8 times. A box with top center alignment, a column that fills the screen, a width-in call to cap the content width on white displays, and a vertical scroll. Population had gone further and hand-rolled an actual 2-pane branch for white windows, checking window width directly in the composable. None of these were wrong exactly, but there were 8 independent places to get it right, and it turned out none of them fully were. There was a modifier ordering bug that silently defeated the width cap on every single screen. In this commit, we replace all of that with one shared composable called Adaptive 2-pane. Route all 8 screens through it and fix the bug once instead of 8 times. The new file lives in core GUI, common main, u.eurostat.ui.layout, adaptive2pane.kotlin. It exposes 3 content slots. Controls and content are the 2 panes you see side by side once the window is wide enough. Controls holds the interactive pieces like country chips and year dropdowns. Content holds the primary payload like a hero chart or KPI tiles. The third slot, compact, is optional and nullable. When a screen provides it, Adaptive 2-pane uses it verbatim below the breakpoint, which matters because several of these screens interleave controls and content in a very specific phone-first order that the designers had already tuned. There is also a controls pane width parameter defaulting to a constant called controls pane width, which is set to 330/20 dp. Inside the composable, isExpanded is computed by reading local euro window width.current and comparing it against euro window width.expanded. That's the material 3 window size class provided further up the tree by Adaptive Scaffold at the app root. So Adaptive 2-pane doesn't need to do any measuring of its own. When expanded, it lays out a fixed width column, hosting the control slot on the left, and a column with weight of 1f, hosting the content slot on the right. Each of those 2 columns gets its own remember scroll state, so the controls rail and the content pane scroll completely independently of each other. You can be scrolled to the bottom of a chart while the country chips above stay pinned near the top. The whole row is kept at controls pane widths plus adaptive content max widths and centered, so a very wide desktop window doesn't stretch the content into unreadable line length. Here's the fix hiding inside this refactor. Every one of the old screens built its content, column with fill max width called first, and then a conditional width-in with a max width applied afterward. That ordering is a no-op. Fill max width forces the incoming minimum width to equal the maximum width the parent offers, and once minimum equals maximum, a width-in max constraint applied afterward has nothing left to shrink. The constraint system won't let the max drop below a minimum that's already fixed, so the content max width cap that every screen thought it had was silently doing nothing. Adaptive 2-pane fixes this by reordering. Width-in with the max constraint runs first, and fill max width runs after it, filling only up to whatever that cap already established. Same 2 modifier calls, opposite order, and now the cap actually applies on every screen that routes through the wrapper. Look at economyscreen.kotlin. The refactor doesn't touch what each section renders. The year dropdown, the metric segmented control, the year scrubber, the country chips row, the headline, the chart card, the secondary metric tiles. All of that logic is untouched. What changes is that each section becomes a named local at composable lambda a year sanction, metric switcher sanction, chart sanction, fill sanction, scrubber sanction, country section, so it can be invoked in more than one order. The control slot calls year, metric switcher, scrubber, and countries. The content slot not shown in full here calls headline, chart, and tiles. And the compact slot calls all 7 sections in the exact sequence the phone layout used before this commit here: headline, metric switcher, chart, tiles, scrubber, countries. So the phone experience is pixel identical to what shipped before. Population screen is the interesting case because it already had a hand-rolled 2-pane layout before this commit, a direct check against window width equals euro window width dot expanded, branching into a row with an euro card weighted at 1F for the population pyramid on the left and a weighted column on the right holding the year slider and a private helper called country sanction expanded. That whole branch, along with the country sanction expanded helper function itself, is deleted in this commit. In its place is one adaptive 2-pane call. Controls gets the metric switcher, year section, and country chips. Content gets the headline and the pyramid card. Compact gets all of them in phone order. The screen that most needed a shared abstraction is exactly the one that had already built its own. And now that duplicate logic is gone for good. Transport Koin surfaces a subtler correctness issue. Before this commit, show country picker was a piece of remembered state declared inside the same conditional block as the country chips row, and the country picker sheet model was nested inside that same block too, meaning both the state and the sheet lived deep inside whatever single column the screen happened to be building at the time. Once a screen has 2 independently scrolling panes, that pattern breaks down. The model needs to sit above both panes, not be a child of one of them. So this commit hoists show country picker to the top of content body as a sibling level remember call, and moves the country picker sheet invocation to run after the adaptive 2-pane call completes as a true sibling in the composition. The sheet now renders exactly once, regardless of whether the screen is showing the stacked compact layout or the side-by-side expanded one. None of this matters if the window never reaches the 840 dp breakpoint in practice. Main.Kotlin, in Compose app's desktop main source set, previously created its window with no explicit size, which meant the JVM desktop target open at whatever small default AWT or swing chose, comfortably under the expanded threshold. This commit adds a remember window state call with a dp size of 1280 dp by 800 dp, wired into the state parameter of the window composable with a comment explaining its size specifically for the 2-pane feature layouts. Without this change, every screen would render its compact branch on desktop by default, and the expanded 2-pane code path, the whole point of this episode, would never actually get exercised by a developer just running the app. To recap, one new composable, adaptive 2-pane, in Core V, 8 feature screens: economy, environment, population, science, social, tourism, trade, and transport, all route their existing sections through it via controls, content, and an optional compact slot that preserves each screen's tuned phone-first ordering. A latent width enough to fill max widths ordering bug present on every old screen is fixed once in the shared wrapper instead of 8 separate times. The desktop window now opens at 1280 by 800, so the expanded layout is actually reachable during manual testing. This is purely structural, no data logic, no intents, no pull to refresh wiring changed across any of the 10 files touched. The full unit suite, the Android APK, and the iOS simulator build all compile green. Run git checkout a 393465 in the repository to land on exactly this state and explore it yourself. Subscribe to follow the rest of the KMP Build series.